All right, so before I get into the actual new material, I just wanted to look at our schedule for this week. Today, I'll be looking at geometric sequences with you. We'll have a video that'll get into a few examples on that. Tomorrow, you're going to do arithmetic, and I'll do another video, arithmetic and geometric series. So we're still working with adding, subtracting, multiplying, arithmetic and geometric, but now we're looking at what a series means, defining that. On Thursday, you'll review. You will not have a class kick, but you'll have some review worksheets to go through. And then on Friday, you will take the quiz. Throughout this week, Mrs. Stone is available 5th hour, especially towards like the second half of the hour. If you have questions, work with each other, run over and ask Mrs. Stone. She'll probably check in on you guys as well, but she is more than happy to answer any questions that you have, especially with the quiz on Friday. So I am available by email as well. So between each other, emailing me, asking Mrs. Stone, you should be in a spot where you feel pretty good about our quiz on Friday. All right? Now, let's look at geometric sequences. Now remember, a sequence is just an ordered pair, or not an ordered pair, an ordered list of numbers. Arithmetic means that in that list you're adding or subtracting. Geometric means that in this list, you might remember this from Algebra 1, in this list of numbers, we are multiplying each time. Now we could be multiplying by a whole number. In that case, the list would be going up, it'd be getting higher and higher. Or we could be multiplying by a fraction, which if we're multiplying by a fraction, that would be like exponential decay. Our list is getting smaller and smaller and smaller. So we don't talk about sequences in terms of division. We always talk about it in terms of multiplication, but it can be increasing where we're multiplying by a whole number, or it could be decreasing where we're multiplying by a fraction. Now, when we are asked to write a rule, did I skip over? I guess I'll write it on here. When we're asked to write a rule for the nth term of the sequence, this would be writing, if you remember the term explicit, this would be the same as writing an explicit formula, a rule for the nth term. And the explicit form of an arithmetic, going back to last week, was a sub n equals a sub 1 plus n minus 1 times d. Now the explicit form, so that we can find the nth term of a geometric, is a sub n equals a sub 1 times r to the n minus 1. I'll come back to that in just a second. Let's look a little bit at this first pattern. If we look at this first pattern, and if we're trying to find the pattern, we can see that we're multiplying each time by 3, times 3, times 3, times 3. This is what's called our common ratio. Whatever we are multiplying by is our common ratio. In our formula, a sub 1 stands for my first term. R stands for my common ratio. So if I'm asked to write a rule for the nth term, or an explicit rule here in number 1, I'd say, all right, a sub n equals my first term, which is 4, times 3, which was my common ratio, to the n minus 1. It then asked me to find my 7th term, so then I would just be plugging 7 in for n, 7 minus 1. So I'm going to type this in my calculator. 4 times 3 to the 7 minus 1, or 6, would give me 2,916. Pretty straightforward. We like writing rules for the nth term. We need to find the first term and then find our common ratio after that. Now here we can see that this pattern is going down. A little cheat to find our common ratio is to do the second term divided by the first term. Right here for me, it's kind of difficult to see what the common ratio is. It's difficult for me to see what we're multiplying. So if I do the second term divided by the first term, this would give me 2/3. So my common ratio is 2/3. This trick works, again, only for a common ratio for a geometric series or a geometric sequence. Now I follow my formula. A sub n equals my first term times my common ratio to the n minus 1. If I want to find the 7th term, technically I should have put a sub 7 equals over there. If I want to find the 7th term, I would just type in my calculator, 9 times 2/3 to the 7 minus 1, which this gives me 64 over 81. It gives me something less than 1, which makes sense because this is going down and down and down and down. That's going to keep getting smaller. So this is how we write a rule for the nth term if we're giving a sequence. We're given the pattern of numbers. Now, they're also going to ask you to write a rule, an explicit rule, when you are given the 2nd term and the 5th, or given 2 just random spots in our pattern. This is a little trickier, but it's not too bad. If we think about our pattern, we have the 1st term, which we don't know. We then have the 2nd term, which we know. We don't know the 3rd, don't know the 4th, and then we know that the 5th is negative 768. Well, if we think about our formula, a sub n equals a sub 1 times r to the n minus 1, we can kind of manipulate this formula a little bit to help us figure out what our 1st term is, because right now we don't have it, and what our common ratio is. So let me show you. It's more like common sense, I'll say, or logical thinking than is following a formula. If this is my 2nd term and this is my 5th, I had to apply my common ratio 1, 2, 3 times to get there. So whatever my common ratio is, I had to apply it 3 times to get from 12 to negative 768. My a sub n, again, it's kind of similar. My a sub n, my term that I'm ending up with, is negative 768. In this case, if I just look at, not here, if I just look at to here, my 1st term was 12. So to find my common ratio, to find my r value, I can use this little cheat sheet. Now I'd have to divide by 12. So negative 768 divided by 12 gave me negative 64. And then I'd have to raise each side to the 1/3 power, or cube root it, which would give me negative 4. So I found my common ratio of negative 4. So that means to get from here to here, I'm multiplying by negative 4 each time. And I could always double check this. I could do 12 times negative 4 times negative 4 times negative 4. Should give me negative 768. Now, to go and find my 1st term, again, it's kind of logical thinking. If I'm at my 2nd, to get from my 1st to my 2nd, I multiply by negative 4. Well, I can divide by negative 4 to go back. So my 1st term would have to be negative 3. So then if I'm writing an equation, I'd have a sub n equals negative 3 times my r value of negative 4 to the n minus 1. If I wasn't sure if I was correct, I could always take 5 and plug it in, and I should get negative 768. So I can always check my answer with something that they give me. But it's more like logical thinking. The first time I had to use logical thinking was with what they gave me. How do I get from here to here? That's what I did here. The second time I had to use what I keep calling logical thinking is to find my 1st term. Okay, I'm at my 2nd term, which to get from my 2nd to my 3rd, I'm multiplying by negative 4. To go backwards, I'd have to divide by negative 4. So that's where I got the negative 3. All you have now with the rest of your time today is the next worksheet in your packet. It's just called geometric sequences. So should be the 2nd page there in your packet.